Hello everyone, welcome to Yamuna's physics classes. We have today a topic refractive index and specifically the two terms absolute refractive index and relative refractive index. There is only a very small marginal difference between the two terms, but most of the cases it gets like a little bit of confused. So just clarifying the two terms. Okay, so we have familiar with the term density, mass density specifically known as mass upon volume. Similarly, a kind of density which measures how fast or how slow light is going through a medium. We know 3 into 10 to the power 8, the magic number known as velocity of light in vacuum. And nearly the same is the velocity in air also. But when you take any other medium other than air or vacuum, we know that the velocity changes. And that's the key for refraction. The change in velocity or the diminishing of velocity in other medium is the only reason why light gets bent when it goes from one medium to another. And optical density or refractive index is a word to specify or to measure what is the extent of this bending. Is it bending more? Is it bending less? We know it is bending either towards or away from the normal. And the extent of bending is actually known as refractive index or optical density. And this is simply the ratio of their velocities in air as well as vacuum to any other medium. So this comparison is known by the term refractive index. So we'll go to the detail. Refractive index or optical density is nothing but it is represented by letters small n or mu. You have another letter known as mu. But here we have chosen small n. How slow light travels in one medium when compared to another medium means you need two numbers or two medium to compare one with another. You have studied the term relative velocity, relative motion means motion of a body when compared with another, or rest and motion itself, two words which are really truly relative. Okay, so we need two media, one compared to another. So that compared means you are taking it with respect to another person known as reference. So in the first case, absolute refractive index, the reference is by default air or vacuum. Whatever, both is correct because there is only very slight difference between the values. This is the refractive index of air, this is the refractive index of vacuum. Actually, this difference results in atmospheric refraction that will come later. But in this particular area, refractive index, we take both are nearly the same. This is 1.00029, the other one is 1. Okay. Now let us go to another example to clarify what is refractive index. So, for example, refractive index of glass, just by saying that, it means you are considering or you are taking the reference as air or vacuum and the value is 1.5. What is the explanation of the term 1.5? It's simply a number. 1.5 is just a number. What we could understand from that? That means you are comparing the glass with respect to air. Means you are comparing the refractive index of glass which is 1.5 to the refractive index of air or vacuum which is 1. Meaning, explaining, from this relation itself I can write velocity of glass is found by. Velocity of glass in that sense, velocity of glass is light as it enters glass or when it travels through glass, the velocity of light is obtained as c upon 1.5. What's the value of c? 3 into 10 to the power 8, you know, divided by n. What is n? 1.5. So what's the answer? 3 by 1.5 goes to 2. 2 into 10 to the power 8 meter per second. Means when light comes from air or vacuum to glass, its velocity slow down by a factor 1.5. Means the velocity just get reduced by a multiple of 1.5. That is the meaning. Or I can again say refractive index is obtained like this way. What is this? Same as velocity of light in air or vacuum divided by velocity in that specific medium. Here the medium is glass. So take 3 into 10 to the power 8 by 2 into 10 to the power 8. You will get the same 1.5. So what did we do? To find the refractive index, it's just enough for you to take the ratio of the velocities with air and the corresponding medium. If it is air, if you are taking it with respect to air, this you can write. So this terminology is known as absolute refractive index. Means the reference is nothing but air or vacuum. I told you, you need one medium and another for reference. But the reference will be for sure air or vacuum in the case of absolute refractive index. Okay. So n is inversely related to V. What do you infer from that? If n is having again much more value, for example, it is diamond, it is 2.4. What do you infer from that? C divided by 2.4 will be the value of velocity of light in diamond. Means it's again less than 2 into 10 to the power 8, much less than 2 into 10 raised to 8. Means as light goes through diamond, the velocity is reduced again to a factor C upon 2.4. That much slow the light has to travel. Clear? Okay. So absolute refractive index is refractive index when measured with respect to vacuum or air. So the comparing medium is any medium compared to air or vacuum. Any medium compared with respect to air or vacuum. So that is known as refractive index or absolute refractive index. Now the second term is relative refractive index. Here the very simple thing, just a correction. Here you can say when travels in one medium compared to another medium, same thing. But it's not air. It can be any other medium other than air. That's all. So you have one medium with respect to another medium, not air or vacuum. Then you will say by the term relative. So here you can have the answer. An example, refractive index of glass. Here it is taken with respect to air. But here you have any other medium other than air. So here you have chosen water. So how to write it? Refractive index of glass with respect to air, right? Refractive index of glass with respect to refractive index of water, not air. And how to get the refractive index? C by Vg divided by C by Vw. Then you put in the reverse and multiply. C and C cancels. So what is the answer? Vw by Vg. So the same. Here you have the same thing. Here you have C. In this case, here you have velocity in that medium, which is the second medium here, Vw. So this is the velocity in air. Here it is the velocity in the other medium, water. So you are considering glass with respect to water here. Here you are taking glass with respect to air. So reference is air in the case of absolute refractive index. In the case of relative refractive index, it will be another medium other than air or vacuum. Clear? So NGW, here the second medium is specified. You have to specify what is the second medium. For sure it's not air or vacuum. Clear? Relative refractive index is the refractive index when measured with respect to any other medium. So in general we will say if it is N12, it means refractive index of 1 with respect to 2. Come back. refractive index of glass with respect to air, water, N1, 2. Refractive index of glass with respect to water. That is N1 by N2. That is N1, 2. Clear? Okay. And N1, how do you write N1? No second medium. What's the second medium? Of course, it's air. So you can simply write N1 or N. Enough to write N. If it is absolute refractive index, it's enough for you to write. You can drop this air. Just write N glass. It's understood. It's understood, meaning glass is compared with respect to air. But if it is any other medium, specify that medium. Whether it is air, water, glass, anything else, you have to specify. So that is N1, refractive index of 1 with respect to air. If you don't write any other indices, it means the second medium or the other medium taken is air. So hope it is clear. Absolute refractive index and relative refractive index. Relative means 1 with respect to 2 and absolute means only 1. The other person understood it is air or vacuum. Clear? If you have again further doubts, please post in the comment box. Thank you for listening. Thank you.